Insulation rods, also known as insulation hanger wires or insulation support wires, are thin, flexible wires used to suspend and support insulation bats in floor joists or ceiling cavities. There are several types of insulation rods. Firstly, there is galvanized steel wire. It's strong and durable, but can be prone to rust. Secondly, there is stainless steel wire. It's more expensive, but rust-resistant. Thirdly, there is plastic coated wire, which can be easier to work with and more resistant to moisture. To use insulation rods to find the bottom plate, firstly, locate the insulation in the floor joist cavity. Use a flashlight or a small camera to inspect the cavity from the basement. Secondly, insert a rod into the insulation. Push the rod into the insulation until it touches something solid. Thirdly, follow the rod. Gently move the rod around to determine if it follows a straight line, which indicates the bottom plate, or curves, indicating a joist. Fourthly, mark the bottom plate. Once you locate the bottom plate, mark its location on the basement ceiling with a pencil or chalk. It is important to be careful not to push the rod too hard, as it may damage the insulation. If you encounter multiple rods in the cavity, try to trace them all to see if they intersect at a common point, which could indicate the location of the bottom plate. You can also use a stud finder to confirm the location of the bottom plate once you have marked it. When working with electrical installations, it is essential to follow the National Electrical Code, or NEC, guidelines for safe and compliant wiring practices. The NEC provides comprehensive standards for electrical installations to protect people and property from electrical hazards. For example, NEC Section 310.15, which discusses ampacity, plays a role in ensuring wires are not overloaded. Ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This is a crucial factor when determining the appropriate wire size for an electrical circuit. Overloading a wire can lead to overheating, insulation damage, and potentially electrical fires. When planning to feed an outside light next to the entry door, the selection of wire gauge is critical. The NEC provides tables, such as Table 310.16, which lists the allowable ampacities for insulated conductors based on their size, insulation type, and ambient temperature. These tables help electricians and homeowners choose the correct wire size for a given circuit load. For instance, if the outside light requires a 15 amp circuit, you would consult Table 310.16 to determine the appropriate wire gauge that can safely handle 15 amps. Common wire gauges used in residential wiring include 14 gauge, 12 gauge, and 10 gauge. Generally, 14 gauge wire is suitable for 15 amp circuits, 12 gauge wire is used for 20 amp circuits, and 10 gauge wire is used for 30 amp circuits. However, it is important to consider the specific installation conditions, such as the length of the wire run and any directing factors that may apply. The length of the wire run affects the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use a voltage drop calculator or consult NEC Chapter 9, which provides formulas and tables for voltage drop calculations. Directing factors are adjustments made to the allowable ampacity of a wire based on factors such as ambient temperature and the number of current carrying conductors in a raceway or cable. High ambient temperatures can reduce the ampacity of a wire, as the wire's insulation may not be able to dissipate heat effectively. The NEC provides directing factors in Table 310.15 that must be applied when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit. Similarly, when multiple current carrying conductors are installed in a raceway or cable, the heat generated by the conductors can raise the overall temperature and reduce the ampacity of each wire. The NEC provides adjustment factors in Table 310.15b3 that must be applied when more than 3 current carrying conductors are installed together. In addition to wire gauge and ampacity, it is also important to select the appropriate type of wire for the application. Common types of wire used in residential wiring include non-metallic sheathed cable, or NM cable, and individual conductors in conduit. NM cable, also known as Romex, is a type of cable that contains two or more insulated conductors and a grounding conductor wrapped in a plastic sheath. It is commonly used for branch circuits in residential buildings. Individual conductors in conduit are used in situations where the wiring needs to be protected from physical damage or moisture. Conduit is a metal or plastic tube that encases the wires and provides a protective barrier. When drilling a hole to feed the outside light, it is important to follow safe drilling practices. Before drilling, make sure to turn off the power to the circuit you will be working on to prevent electrical shock. Use a stud finder to locate the studs in the wall and avoid drilling into them. If you need to drill through a stud, drill in the center of the stud to avoid weakening it. When drilling through the wall, be careful not to damage any existing wiring or plumbing. Use a drill bit that is the appropriate size for the wire or cable you will be running. After drilling the hole, use a cable stapler or cable ties to secure the wire or cable to the wall. This will prevent the wire or cable from moving around and potentially becoming damaged. It is also important to properly ground the outside light fixture. Grounding is the process of connecting the metal parts of an electrical appliance or fixture to the earth through a grounding conductor. This provides a path for fault current to flow back to the source in the event of a short circuit, tripping the circuit breaker and preventing electrical shock. The NEC requires all metal parts of an electrical fixture to be grounded, including the metal box that the fixture is mounted to. To ground the fixture, connect the grounding conductor from the fixture to the grounding conductor in the electrical box. The grounding conductor is typically a bare copper wire or a green insulated wire. In addition to following the NEC guidelines, it is also important to follow local electrical codes and regulations. Local codes may have additional requirements or restrictions that you need to be aware of. It is always a good idea to consult with a qualified electrician if you are unsure about any aspect of the electrical installation. A qualified electrician can help you ensure that the wiring is done safely and in compliance with all applicable codes and regulations. Furthermore, consider the environment where the wiring will be installed. For outdoor lighting, you need to use wiring and fixtures that are rated for wet locations. This ensures that they can withstand moisture and prevent electrical hazards. Look for the UL wet location listed marking on the products you choose. This certification indicates that the product has been tested and approved for use in wet environments. Consider using ground fault circuit interrupters, or GFCIs, for outdoor circuits. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly shutting off the power. They are particularly important in areas where water is present, such as outdoor lighting circuits. The NEC requires GFCIs to be installed in all outdoor receptacles and in certain other locations where there is a high risk of electrical shock. When running wires through walls or ceilings, protect them from physical damage by using conduit or cable protectors. This is especially important in areas where the wires may be exposed to nails, screws, or other sharp objects. Conduit and cable protectors can help prevent damage to the insulation, which could lead to electrical shorts or fires. Always label your circuits clearly. This will make it easier to identify and troubleshoot problems in the future. Use a permanent marker or label maker to label the circuit breakers in your electrical panel and the corresponding outlets and switches. This will save you time and frustration when you need to work on the electrical system. Remember to obtain the necessary permits before starting any electrical work. Many jurisdictions require permits for electrical installations to ensure that the work is done safely and in compliance with local codes. Check with your local building department to determine the permit requirements in your area. Finally, never work on electrical systems when you are tired, distracted, or under the influence of drugs or alcohol. Electrical work requires focus and attention to detail. Make sure you are in a clear and alert state of mind before starting any electrical project. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and your property. In addition to the above considerations, there are several other factors that may affect the selection and installation of wiring for an outside light. For example, the type of light fixture you are using will affect the amount of current that the circuit needs to carry. LED light fixtures typically draw less current than incandescent or halogen fixtures, so you may be able to use a smaller wire gauge. The distance from the electrical panel to the light fixture will also affect the wire gauge. The longer the distance, the greater the voltage drop, so you may need to use a larger wire gauge to compensate. The ambient temperature will also affect the wire gauge. If the wire will be exposed to high temperatures, you may need to use a wire with a higher temperature rating. The type of insulation on the wire will also affect the wire gauge. Some types of insulation are more resistant to heat and moisture than others, so you may be able to use a smaller wire gauge if you use a wire with a higher quality insulation. The number of wires in the conduit will also affect the wire gauge. The more wires in the conduit, the more heat will be generated, so you may need to use a larger wire gauge to compensate. The type of conduit you are using will also affect the wire gauge. Some types of conduit are more effective at dissipating heat than others, so you may be able to use a smaller wire gauge if you use a conduit that is more effective at dissipating heat. The type of connectors you are using will also affect the wire gauge. Some types of connectors are more resistant to corrosion than others, so you may be able to use a smaller wire gauge if you use connectors that are more resistant to corrosion. The type of grounding system you are using will also affect the wire gauge. Some types of grounding systems are more effective at protecting against electrical shock than others, so you may be able to use a smaller wire gauge if you use a grounding system that is more effective at protecting against electrical shock. The age of the wiring in your home will also affect the wire gauge. If your home has older wiring, it may not be able to handle the same amount of current as new wiring, so you may need to use a larger wire gauge. The condition of the wiring in your home will also affect the wire gauge. If your wiring is damaged or corroded, it may not be able to handle the same amount of current as new wiring, so you may need to replace the wiring. The presence of any electrical hazards in your home will also affect the wire gauge. If there are any electrical hazards in your home, such as exposed wires or overloaded circuits, you will need to address these hazards before installing the outside light. In addition to these factors, it is also important to consider your personal safety when working with electricity. Always turn off the power to the circuit before working on it. Wear safety glasses and gloves to protect yourself from electrical shock. Use insulated tools to avoid contact with live wires. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these safety precautions, you can help prevent electrical shock and other electrical hazards.